Hello students, today we are going to discuss the topic that is water demand. Now the water demand comprises of 6 parts, that is the domestic water demand which will be used in the domestic purposes like drinking, cooking, cleaning, etc. Okay. Next one will be the industrial water demand which will be used by industries. Okay. Next will be the institutional water demand, the water which will be used in the institutes for drinking purpose, for flushing of water closets comes under institutional water demand. Next will be the public water demand, the water which will be used for the development of parks, for the washing of roads comes under public water demand. Next will be the fire demand. This is the most important demand in the water demand topic, because if Gates wants to ask any question from water demand, then 99% chances will be there that the question is from fire demand. Okay, now this is the amount of water which will be used for the fire extinguishing purpose, which will comes under fire demand. Next will be the water demand for losses and theft. Now we will see one by one each and every water demand in detail. Okay, now the first will be the domestic water demand. It is the amount of water required to satisfy domestic needs like drinking, cooking, washing, bathing, etc. Okay, domestic water will be used for drinking, cooking, bathing, washing, flushing, etc. Now, for higher income group or for full flushing system, it generally varies between 135 to 225 liter per capita per day. Normally taken to be 200 liter per capita per day. But as a civil engineer or as an environmental engineer, we will go for the worst scenario, that is for the economically weaker section. For economically weaker section, the domestic water demand generally in the range of 135 liter per capita per day. So our domestic water demand is generally taken to be 135 liter per capita per day. Now we will see the bifurcation of domestic water demand. The first bifurcation will be for drinking purpose. For drinking purpose, the amount of water required will be 5 liter per capita per day. For cooking purpose, it will be 5 liter per capita per day. For bathing purpose, the value will be slightly higher side, that is 55 liter per capita per day, because we had assumed that a person will take bath at least 2 times in a day. That's why the consumption will be 55 liter per capita per day. Next will be the washing of clothes. Now the amount of water required for washing of clothes will be 20 liter per capita per day. For washing of utensils, 10 liter per capita per day. For washing and cleaning of houses and residences, the consumption will be 10 liter per capita per day. Now suppose that if in a family there will be 5 people living, now the amount of water required for washing of house will be, we directly get the value by multiplying the number of people living in that family by the per capita demand. We will get the amount of water, that is 50 liter per day will be the amount of water required for washing and cleaning of houses and residences. Okay, now the next important use will be flushing of water closets, etc. The amount of water required for flushing of water closet will be 30 liter per capita per day. Now if we do the sum of all these values, then it will comes as 135 liter per capita per day, which is the domestic water demand as per the economically weaker sections. Okay, now the next demand will be the industrial water demand. It is the amount of water required to satisfy the industrial needs. Why we want to satisfy that needs? Because we need this water for satisfying the industrial needs, and it will generally varies in between 50 to 450 liter per capita per day depending on the type of industries. Okay, now if in a city there will be a sugar industry or textile industry, then the amount of water consumption will be on a higher side, that is 400 to 450 liter per capita per day. So industrial water demand generally depends upon the types of industry. Now the next will be the institutional water demand. Now it is the amount of water required to satisfy the needs of different institutes in a particular locality like schools, hospitals, etc. Where we use this demand? In schools, colleges, hospitals, etc. Okay. Now the demand generally varies between 20 to 50 liter per capita per day, because in school, colleges, hospitals, the water is required for cleaning purpose, for drinking purpose, for flushing purpose. That's why the amount of water in institutional water demand will be less as compared to the industrial water demand. Okay. Now next will be the water for public use. Generally, water for public use generally uses the water for the park development, for washing of roads, etc. So the amount of water required for public use will be very low, as in the range of 10 to 20 liter per capita per day. Okay. Now the next demand, that is the most important demand, which will be known as fire demand. Now for a city of 50 lakh population, fire demand hardly amounts to 1 liter per capita per day. Okay. Now if we want to compute the approximate value of fire demand for extinguishing fire for a city of 50 lakh population, it hardly amounts to 1 liter per capita per day. It means that in a particular city of 50 lakh population, we had 50 lakh liter of water, 50 lakh liter of water per day for fire extinguishing purpose. Okay. Now this will be the approximate amount of water required for extinguishing fire. If we want to compute exact quantity or more accurate quantity of fire demand, then we use or we need to use certain empirical formulas, which will be Kuchling's formula, Freeman's formula, Burston's formula, and National Board formula. Now the first formula, that is the Kuchling formula, is very important from the fire demand topic, because GATE had every time GATE had asked question from the Kuchling's formula only, which will be equals to Q equals to 3182 root P, where Q is the amount of water required for fire extinguishing. Amount of water required for fire extinguishing. Okay, required for fire extinguishing, and it will generally comes as liter per minute. Okay, it will generally comes as liter per minute. Okay. Now the value of P here is equals to population in thousands. Now what is population in thousands? Suppose that we have a population of a city that is equals to 40,000. Now if we want to compute the value of P, we just need to divide that population with 1000, and we will get the value of P as 40. So if we want to compute the value of P, we only need to divide that population with 1000, and we will calculate the value of P. Okay. Now according to Kuchling formula, Q equals to 3182 root P. Similarly, according to Freeman's formula, Q equals to 1136 P by 10 plus 10. Only the constants had been changed, rest other thing will be same. Now next will be the Burston's formula, which will be equals to 5663 root P, where P is in population in thousands and Q is the amount of water in liter per minute. Okay. Now next will be the National Board formula. Now National Board formula had been bifurcated in two parts. When the population of city is less than equals to 2 lakhs, then formula will be used for computing the amount of water, which will be equals to 4637 root P 1 minus 0.01 root P. And if population is greater than 2 lakh, then a provision of 54,600 liter per minute may be made, with an extra additional provision of 9100 to 36,400 liter per minute for a second fire. Now we will describe this sentence in detail. Suppose that if in a particular city fire catches, okay, now we want extinguishing that fire, so we will supply the water at the rate of 54,600 liter per minute for the first fire. Suppose that after supplying this much amount of water, the fire completely extinguished. Okay. Now after some time, when second fire again catches on same place, now we need to supply the amount of water at the rate of 9100 to 36,400 liter per minute for second extinguishing. Okay, that will be the National Board formula. And we had already discussed that the Q is amount of water required in liter per minute and P is the population in 1000. But GATE had asked always the Q in Q max. Okay, the amount of water, always GATE had asked the amount of water in Q max. What is Q max? It will be equals to meter cube per second. Okay, now we need to convert the liter per minute into meter cube per second. Now we know that in 1 meter cube there will be 1000 liter. Okay. Now in 1 liter there will be 10 to the power minus 3 meter cube. So we had just multiplied the numerator with 10 to the power minus 3 and we had converted the liter into meter cube. Okay. Now in 1 minute there will be 60 seconds. So what will be the conversion factor? It will be equals to 1 by 60,000 and we had converted the liter per minute into meter cube per second by multiplying it with 1 by 60,000. Okay, that will be the fire demand formulas. Okay, now the next will be the water demand for losses and theft. Suppose that if in a particular pipe where the water is flowing, if any crack develops, then the water starts leakaging from that crack. Okay, that type of water comes under water demand for losses and theft, and it may be as high as 15% of the total demand. So we had discussed the total domestic water demand, which will be equals to the total domestic water demand, which will be equals to how much? It will be equals to 135 liter per capita per day. Similarly, the total water demand means the sum of all the demands. Now the total water demand will be equals to 270 liter per capita per day. These two values are very important from all the government exams point of view as well as from the GATE point of view. Okay. Now that is all about the water demand. Moving on to the next, that is per capita demand. Now what is per capita demand? It is the annual average amount of daily water required by one person and includes the domestic use, industrial use, commercial use, public use, waste, theft, etc. What it means? It means that the amount of water required by one person for all the demands in liter in one day is known as per capita demand. Suppose that for a particular city we had provided V liters of water in 1 year. Now we want to compute the 1 day demand. So we had divided this value by 365 because in 1 year there will be 365 days. So we had computed the 1 day demand as V by 365. Now if we want to compute the per capita demand, it means that we want to compute the per person demand in 1 day, we need to divide this value by the design population. So the per capita demand will be equals to V in liter divided by 365 into design population, and it will be represented by small q. That will be the per capita demand. Okay. Now the next will be the factors affecting the water demand. What are the factors which will affect the water demand? First will be the size of city. Now the size of city will be directly proportional to the water demand. As the size of city increases, water demand also increases. Similarly, in climatic condition, suppose that if there will be a summer season, then the water demand will be very high as compared to the rainy or winter season. Next one is the quality of water. Quality of water is also directly proportional to the water demand. Suppose that we had provided one person with mineral water, then they will consume that water. Now if we provide this same person with sewage water, then they will not consume that water. So if the quality of water is very high, then the water demand will be also very high. Now the next one is the cost of water. Cost of water is inversely proportional to the water demand. As the cost of water increases, water demand will decrease. Similarly, pressure in the distribution system, it will also be directly proportional to the water demand. Suppose that in morning time you had gone to your washroom and you want to fill that bucket with water for bathing purpose. Now if one drop takes 10 minutes to fall in that bucket, now another drop will take another 10 minutes. So do you take bath? Definitely not, because one drop will take 10 minutes to fall into that bucket. So you will not take bath because pressure in the distribution system is very less. We take another case. Suppose that if you open the tap of your washroom and the complete bucket will be filled within 5 to 6 seconds, so you will use more amount of water for the bathing purpose. So pressure is directly proportional to the water demand. Now we have discussed the industrial and commercial activity. As the more and more industry that will require more water will be there in the city, then the water demand will be very high. Okay. Now habits of people. It will depend on the type of people. If some people is having habit to wash the hand after every 5 to 10 minutes, then the water demand will be high. And some person is having habits that they will not wash hands or they will not wash their faces on regular basis, then the water demand will be very low. So it will be depends on the people's habit. Okay, it will depends upon the people's habit. Now next will be the development of sewage facility. In the older times, the flushing tank which will be provided in our washroom will have only one switch. Now if we want the water for urine discharge or for human excreta solid discharge, we will just press that switch and almost 5 to 10 liter of water will be flushed out at a single time. Okay, now we had developed that flushing tank. Now we had provided two types of switches, one for urine discharge and another for solid waste discharge. Now if we want to flush the urine, then we will press the small switch which will discharge at an amount of 1 to 2 liters of water for urine disposal, and for human excreta or for human solid waste we will press the larger switch which will discharge 5 to 10 liters of water. So by development of sewage facility, we had reduces the water demand. Okay. Now the next will be the facility of metering and method of charging. Now suppose that if in front of your house there will be a meter which will read all the amount of water which will be used in the house. So if every drop will be recorded in that meter, then you will use less amount of water because you need to pay for each and every drop. Now you will use less amount of water. But suppose a case will be there when there will be no meter in front of your house, then you will use as much amount of water as you will. Okay. So facility of metering also decreases the water demand. Okay. Now that are the factors which affect the water demand. Now the note will be there. The first note will be in intermittent supply system. Intermittent supply system is what? In which the water is generally comes in the house for a particular interval of time, that is for 1 or 2 hours. Now what are the habits of our sisters, our mothers, that in between these 2 hours when the water will be there in our houses, they will fill all the small to larger containers with water. Okay, and in the next day when the fresh supply again comes, they will throw this water if unutilized. Okay, now in this way we had increased the wastage and losses considerably. So in the intermittent system, the losses in wastage and other ways generally increases considerably. Clear? Now the next note will be the cost of water is inversely proportional to the consumption of water, which we had already discussed in the fourth point of the factors affecting the water demand. Now the last one will be the loss of waste due to leakage are considerably increased if pressure is high. We definitely know it. If the pressure in the distribution system is high, and suppose that if any crack develops, then the amount of water which will be lost out from that crack will be very high. So the loss of waste due to leakage are considerably increased if pressure is high. That is all about the factors affecting the water demand. Okay. Now the next will be the variation in the demand. Now we need to discuss the variation in the demand because it is important from all the exams point of view as well as from the gate point of view. Now the first variation will be the maximum daily demand. Okay, first variation will be the maximum daily demand. It will be equals to 1.8 times of average daily demand. Now how can we compute the average daily demand and maximum daily demand? Suppose that in a particular week we had 7 days data. Now we divide that 7 days data by 7, we get the average daily demand. Now if we want to compute the maximum daily demand, we need to multiply the average daily demand with 1.8. Okay. Now the second will be the maximum weekly demand. Maximum weekly demand. Now maximum weekly demand will be equals to 1.48 times of average weekly demand. Now how can we compute the average weekly demand? Suppose that in a particular year we have 52 weeks. Okay, now we have 52 weeks data. Now we just add all these 52 weeks data and divided it by 52. we will get the average weekly data. Now if we want to compute the maximum weekly demand, we will need to multiply the average weekly demand by 1.48. Now the next will be the maximum monthly demand. Now the maximum monthly demand generally varies as 1.28 times of average monthly demand. 1.28 times of average monthly demand. Now how can we compute the average monthly demand? In a particular year we had 12 months and we had 12 months data. So we will add all these 12 months data and divide it by 12, we will get the average monthly demand. Now if we want to compute the maximum monthly demand, now we need to multiply the average monthly demand by 1.28. Now the next variation will be very important, that is the maximum hourly demand. Okay, now the next will be the maximum hourly demand. It will be equals to 1.5 times of maximum daily demand, which we had discussed in the first point, maximum daily demand. Now maximum daily demand will be equals to 1.8 times of average daily demand. Okay, now if we multiply the 1.5 with 1.8, we will get the value of 2.7 into average daily demand. Now we want this data as hourly basis, so we had average daily demand. Now in one day how many hours will be there? There will be 24 hours. So we just divide that value, that is average daily demand, by 24 and we will get the data or the maximum hourly demand in terms of average hourly demand. We need to multiply it with 2.7. Okay, now the next will be the coincident draft, which will be very important as per the GATE exam, that is the coincident draft. Now coincident draft will be equals to the maximum daily demand plus fire demand. Maximum daily demand plus fire demand. Now you need to compute the fire demand as per the 4 formulas. Okay, and you need to compute the maximum daily demand and just add both these value, you will get the coincident draft, which will be equals to maximum daily demand plus fire demand. Now the next will be the total draft. Total draft. Now the total draft will be maximum of, okay, it will be maximum of, what will be the value? That is the maximum daily demand plus fire demand. Okay, maximum daily demand plus fire demand, and the next will be the maximum hourly demand. From both these values, the maximum value will be the total draft, that is maximum daily demand plus fire demand or maximum hourly demand. Okay, that is all about the demand or the water demand. Okay, thank you very much.